Good day, grade 12 learners. Welcome to today's physical science lesson. My name is Mashudu Mamburu. Today we'll be revising physics, which is paper 1. So that will be our focus. And we are saying the format of your question paper in terms of prelim and final exam, as stated in the exam guideline, is that we have two types of questions that you'll expect. That is your multiple choice questions and what we refer to as structured questions. So multiple choice questions will still be your 20 marks, which is about your 13% of your paper. And then the rest, 130 marks, will come from structured questions. So you are expecting about 9, 10 questions or so. And then in those 10 questions, we are saying structured questions, 130 marks. Multiple choice questions, 20 marks. So it's important that you spend some time doing your multiple choice questions and ensure that you get that those 20 marks. I think it's very much important that you do as well in multiple choice questions. Usually our multiple choice questions are taken from each of the sections that we do. So that is under mechanics, you'll have your Newton's laws, and then you will have your vertical projectile motion, your momentum, your work energy and power, your Doppler effect, your electrostatics, your electricity, your electrodynamics, that is motors and generators, and then lastly your photoelectric effect. So you're expecting at least a multiple choice question from each of those sections that I just indicated. Now, in terms of marks, the exam guideline says mechanics, we have 65 marks from mechanics. Doppler effect or wave, sound and light, we have 15 marks from wave, sound and light. Electricity and magnetism, we have 55 marks. So you can see it's as important to do electricity and magnetism and do it well. So let our focus not be in one of the two sections. Both mechanics and electricity and magnetism must be given a right attention in order for you to be able to get all these marks. And then lastly, we have metal materials. In this case, metal materials, we are referring to our photoelectric effect. Now you will check in this term, in term 3, you have done electrodynamics, your motors and generators. I think they are still fresh with yourselves. And then you have done your photoelectric effect. You will definitely tap into them. It's always good when you are revising to start by revising these topics that you were doing just now, so that you capture everything and you get all of those marks. So I think when you are still fresh, ensure that electrodynamics, photoelectric effect, you spend some time doing those topics. You do them, you put them aside, then you focus on your term 1 and term 2 topics, because there will be a lot of marks as well that will come. Remember, mechanics, you have done it in term 1. In term 2, you have done work, energy and power under mechanics. So you can see it's mostly term 1 and term 2, your Doppler effect in term 2 as well. Then term 3, you were able to do your electricity with the focus on internal resistance. Remember now, internal resistance is part of our syllabus now in grade 12. So it's important that as you prepare, you always balance yourself. Don't just do only term 3 topics that you still remember. Please spend more time with your term 1 and term 2 topics, which is the focus of this lesson. We'll definitely focus mostly on those topics so that we are able to remind you, and then you are able to be ready for these exams. Hence, we are saying about 60 minutes we'll spend on mechanics, Doppler effect about 9 minutes, 21 minutes in electricity and magnetism. And then before I start, I want to say revision sharpens your skills. So I'm not coming here with a question paper that you will find tomorrow, but I'm coming here with skills that you will need to answer any physical science question. So our focus in this lesson is exam skills and techniques, to say what are the skills that you need when you find a question like this, because everyone who has the skills will be able to answer questions, no matter it can be new questions. As long as you have the right skills for that particular section, you will be able to apply the skills and you will be able to answer the question. So we're saying this is a chance to prepare for exam-style questions. So we're going to look at exam-style questions to say this is how questions are asked in the exam, and then this is how we're expecting you to respond. Now, definitely, we always start with our Newton's laws of motion and forces, which is you're expecting this question in the second question there to say Newton's laws of motion. Now, we always start with Newton's first law, which refer to these two things which are important. The first thing is that F net equals to 0, and then we are saying an object is at rest. The object will remain at rest or moving at constant velocity unless acted upon by an external resultant force. As long as there is no F net that is acting on that object, we are saying that the object will remain at rest or will continue to move at constant velocity. Be aware of these two scenarios when you are answering questions, whether the object is at rest or the object is moving with constant velocity. Remember, if the object is moving with constant velocity, we are saying the forces are balanced. The forces are balanced. We have balanced forces. Then we know that the object is moving with constant velocity. We'll talk about equilibrium there to say the forces are at equilibrium. So the forces can be at equilibrium while the object is in motion. So it's important that you have that understanding to say, okay, when we say the object is moving, but the forces are at equilibrium, are in equilibrium, we are simply saying that the object is moving with constant velocity. So constant velocity, we're saying your forces are balanced. We're saying the forces are in equilibrium. So don't forget all that in terms of Newton's first law. F net equals to 0 newtons. In terms of Newton's second law, we are saying when this net force is applied on an object, the net force is no longer equals to 0. We now, in Newton's second law, have the net force. And we are saying that you have that formula from your data sheet, F net equals to ma. Always is there to remind yourself to say when a net force is applied on the object will accelerate in the direction of the net force. And we are saying that the acceleration is directly proportional to the net force, and acceleration is inversely proportional to the mass. Always you'll write that in weights, and you are able to get your 2 marks. And we are saying in terms of Newton's third law, two bodies, we are saying if an object A exerts a force on object B will exert an equal but opposite force on object A. So you are able to see that this is all the laws that you must be able to state all of them, and that is the expectation as we move. Now we are saying problem solving. When it comes to problem solving here, we are always emphasizing the importance of the free body diagram. Remember, you don't draw the free body diagram for the one that is asked only in the question. You can even draw the free body diagram for you to be able to answer other questions, because without knowing which forces are acting on an object, it will be difficult for you to do this. And this is important because you are going to do the free body and force diagrams in question 2, which is your Newton's laws. And when you do your work, energy and power, you will still be able to identify. You need to identify the forces acting on the object in both Newton's laws and work, energy and power. As well, you will be asked the same question can be asked under electrostatics to say draw the free body or the force diagram. So it's important that you have that knowledge of how to go about doing that. And we are saying underline keywords. We have keywords like rough surface. Immediately when you see rough surface, you know we are saying there is friction. Friction is involved. When you say smooth surface, we are saying frictionless, or there is no friction. You know that when you say the smooth surface, we are saying friction is there, but it's very little, in a way that we ignore it. So we are saying that is a smooth surface will be a frictionless surface. A rough surface will have friction. And we are saying pay careful attention to the mark allocation. We are always emphasizing that to say if a question is 3 marks, definitely you know that is a routine question. And we are always saying you will write your formula, you will do your substitution, you will write your answer with correct SI unit and direction. Hence we are saying always saying FSAUD to say always remember. We are saying that identify the correct formula, substitute, write the answer with correct SI unit and give direction if you are dealing with vectors. Remember, we always penalize you the mark. If you don't indicate the direction, you just show the magnitude of a vector, because a vector has got both magnitude and direction. And then marks more than 4 marks, definitely you know that will be your multi-step calculation. So you are able to see that when it's 4 marks or more, definitely it needs more of you to do the calculations so that you are able to get all the marks. So I'm hoping that will help you as we go to do questions. But we're saying you can't do questions without going through the data sheet. And we're saying when you go to data sheet, you are going armed with data that you have collected. So when you get the statement, you have given information there. You are able to identify all the important information that you are going to address in the data sheet there, so that you are able to choose the correct formula. Because for you to get the mark, you must be able to identify the correct formula and be able to substitute in that particular formula. So we're saying if there is no substitution, you just write the formula. We're not going to mark the formula because the formula you just took it from our data sheet. Hence, we're saying trace this formula. You be able to take information from the statement and write it underneath that formula in order for you to get a mark for identifying the correct formula and a mark for substitution. So if you do that correctly, you will definitely be able to collect marks. And we're saying with our data sheet again, remember Newton's second law. You are able to come here and it will always remind you when a net force is applied on the object will accelerate in the direction of the net force. Don't forget, you make acceleration subject of the formula in order for you to say acceleration is directly proportional to the net force and acceleration is inversely proportional to mass. Then you are able to always use that as a point of reference. And as you look at this data sheet for forces, as well, you are having your maximum static frictional force, and your maximum your kinetic frictional force as well. Your kinetic frictional force, your maximum static frictional force. Then you are able to calculate static friction, maximum static friction, and kinetic friction as well, depending. So if you are given the coefficient of static friction or coefficient of kinetic friction, you are able to calculate each of them respectively like that. And we are saying this formula is very much important because it's a point when you are thinking about doing the calculations, you will always refer here and you don't come here without the data that you have collected, because the data will always remind you which formula to choose. And we are saying, don't forget as well, we have the gravitational force for universal gravity. We have the force for universal gravitation there, your F. Then or as well be able to utilize that formula as well. And it's very much important when you're dealing with this particular formula to understand the relationship between the force and the mass, and the force and the square of the distance between the objects. So it's important that you see that as long as whatever is happening, the force is directly proportional to the product of these masses M1 and M2, directly proportional, meaning that if we double the M, definitely we're going to double the force. But if we double both M1 and M2, definitely come and substitute there. When you double M1, you will substitute M there, which becomes 2 there. Then you are able to see that as we double the mass, we are able to double the force. The same, if we double both masses, be able as well to do the same. This question is one of the questions that in the multiple choice questions that you will come across to be able to see that, okay, what happens if we double the mass? Just substitute to say if we double the mass, it will be 2m1 multiplied by m2 over r squared. Then you are able to remove the 2 there. You remain with your gm1 m2 over r squared, which is your force. So you can see that as you double the mass, you double the force. And then if you double m1 and m2, definitely it will be 2 times 2, which means the force will be 4 times more. And then the same, what is the relationship now when we increase the distance? We can double the distance, be able there to always remember when you double the distance, it will be 2r all squared. When you double the distance, 2r all squared, which means now it becomes 4r squared, which means definitely when you are increasing the distance, the force will decrease because they are inversely proportional. But you are able to see that when you double the distance, the force will decrease by 1 over 4. So you'll be able to get 1 over 4 force there that is quarter of that particular force, and be able to understand that if we halve the distance, the r there, if we halve the r, be able to see that when you have the r, where the distance is becoming small, definitely the force must increase. So you are able to see that you must write r over 2 squared. So you're able to see that you will get r squared over 2 over 4, which definitely is 1 over 4. And when you multiply that, you will be able to get that the force will increase by 4 times. So know the relationship. When we increase the r, we're saying the force will decrease. But when we decrease the distance between the two bodies, definitely we are saying that when we decrease the distance, the force will increase. So always I wanted to emphasize that, so that you don't lose marks. Even in multiple choice questions, you get such questions and be able to interpret this information. Now, without any wasting of time, today we are more about questions. We are more about how are we going to solve problem solving. It's less of talk, but more of problem solving. And then definitely, as I indicated, I said to yourselves that it's important that you understand that what we are giving you here is the skill of how do you go about responding to multiple choice questions like this one. Now, this one is saying several forces are acting on a moving object. So it's very much important, because you know exactly that we can have a body at rest, we can have an object that is moving. So this one is a moving object. Which one of the following is correct? When the forces are in equilibrium, you are able to know which law talks about the forces in equilibrium. Oh, I just told you about balanced forces. Balanced forces, they are at equilibrium. So you are able to see that, okay, the forces are in equilibrium. It means the forces are balanced. Now, you know when the forces are balanced, which law is that one? Is Newton's first law. Remember Newton's first law? We said when an object will remain at rest or moving with constant velocity unless acted upon by an external resultant force, unless there is an unbalanced force now that is going to unbalance everything. So we are saying now, which law is that? Newton's first law. So the question is saying, which of the following statement is correct for when forces are in equilibrium? So we're saying the velocity of the object is increasing. No. The object is moving at constant velocity. Equilibrium, yes. Constant velocity, balanced forces. Constant velocity, balanced forces in equilibrium. So definitely you are able to get your answer because you have studied and you know your law. So you see that these multiple choice questions, they can be based on application of the laws that you have done already. This was the question, multiple choice questions in 2024 final exam. And then let's look at the second question now, which is multiple choice question again, 1.2 from November 2024. The question was, a stone is thrown vertically downwards. A stone is thrown vertically downwards from the top of the building. Of a building takes time t seconds to strike the ground. Consider the acceleration time graph for the motion of the stone. The effects of air friction are ignored. What does the shaded area between 0 and t seconds shown in the graph represent? So it's very much important for you to have an understanding to say our graphs, they always have the y-axis and the x-axis. Remember, as I emphasized that here we're giving the skill, whichever graph you get, you are able to interpret that graph and have correct information. And then what are we saying? We're saying if you say change in y over change in x, you're going to get the gradient of the graph. That gives you the gradient of the graph, and then which is change in y over change in x. But now, in this case, they are saying now, what does the shaded area between 0 and t, this shaded area between 0 and t shown in the graph represent? So we are simply saying now, for gradient, we say change in y over change in x. But when it comes now to the area under the graph, we are saying now is the multiplication of y multiplied by x. Y multiplied by x. And if you check, that will be acceleration, which is your y, multiplied by time, delta t. And a delta t definitely that is your change in velocity. By definition, you know what is acceleration? We are saying acceleration is the rate of change in velocity. So definitely, if you are to do the cross multiplying there, acceleration over 1, you are able to get delta V equals to A delta T, which now shows you now that you are able to see that. So now it's important when you come to the options, already you know that I'm talking about the area under the graph. It means I'm multiplying A times delta T. And even if you can use the SI unit, you know that acceleration is in meters per second squared. If you multiply meters per second squared by second, which is time, definitely you will get meters per second. And meters per second is what? Is your velocity. So you are able to see that, okay, this graph represents option number 1, A, the final velocity of the stone, B, the change in position of the stone, constant velocity of the stone, change in velocity of the stone, correct. So you see that acceleration is the rate of change in velocity. So this A delta T, which is the area under this graph, definitely will be able to show us the change in velocity of the stone. So you are able now to choose D, and you are 100% that you are able to answer the question. I hope this helps you not only with this graph, with any other graph, to be able to understand that when I say change in y over change in x, I'm talking to the gradient. When I say y times x, I'm talking about area under that particular graph. In this case, the area under acceleration time graph, we're saying it shows us velocity. The same, if we can give you velocity time graph, you will be able to know that the area under velocity time graph, that is now your v times delta t. So you just simply go to the definition of what is definition of your velocity, which is the rate of change in displacement. Definitely that will be your delta x, the area under this particular graph. But if you were to get the gradient under velocity time graph, the gradient, it will be change in v over change in time, which in this case, change in v over change in time is acceleration. So be able to have that knowledge to say, okay, the gradient under the velocity time graph will give me acceleration. But now the area under velocity time graph, definitely it will give me a change in x, my displacement. The area under acceleration time graph will definitely give me change in velocity. So I hope this helps you not only on this question, but for any other question that you will get that is have to deal with graphs like this one. Now, let's look again, question 2. We are having here two blocks of mass 4 kg and block B of mass 9 kg. So you can see, as indicated, they are going connected by a light inextensible string. The blocks are held at rest on a plane that is inclined at angle of 35 degrees with horizontal. A constant force, you can see we have a constant force is applied, acting parallel to the plane, is applied to block B. And then, as shown in the diagram, the blocks now accelerate with acceleration of 2 meters per second squared. Important for you to be able to underline that critical information that you will need to say, now these blocks are now accelerating, and the acceleration is 2 meters per second squared. Now, state Newton's second law of motion in waves. I hope by now you are singing it, to say when a net force is applied on the object will accelerate in the direction of the net force. And you are saying acceleration is directly proportional to the net force, and acceleration is inversely proportional to the mass. So you are able to write that in your ways, and then you are able to get your 2 marks. Now, the next question, draw a free body diagram. Draw a free body diagram showing all forces acting on block A. All forces acting on block A. So you got to, don't make a mistake. If the question is about block A, draw block A. What are the forces? You can see that already we have a string, and the force that we find on the string, we call it the tensional force. So definitely you will have tension. You have heard here, we have talked about this object that are on this plane, and then they've indicated that the two blocks of mass 4 kg A 9 kg are connected by light inextensible string. The blocks are held at rest on a plane that is inclined at an angle of 35 with horizontal. A constant force F acting parallel to the plane is applied. But the statement that is more important that I'm looking for is this statement: the kinetic frictional force acting on blocks A and B is given there respectively. So if you miss that statement, you'll be missing that there is frictional force that is involved. So it's important that you always look for keywords like those that might be hidden somewhere in the statement. You must be able to see that, okay, we have kinetic frictional forces that were given on A and B respectively. Definitely there is friction. So you can see on block A, we're having tension, we're having our frictional force, and then there is a popular force that is always there, which is your Fg. Fg is always there. When we are drawing our free body diagrams, there will be Fg. It's meaning that you have that one mark of drawing Fg because it's there. And because now we're having the surface, we have the normal force as well. Remember, the normal force must be normal. What do I mean by that? I mean that the normal force must be perpendicular to the surface. Always perpendicular to the surface. So that's how you will draw your tension, your friction, your normal force, your weight. But the most important thing here is that don't be too excited, and not your forces must always start from the dot there. And there must always be arrowheads. And be careful not to draw your arrowheads like that, because you are in hurry, and then you find that the arrowhead is no longer in touch with the force that is representing. So those small things, or you find that your line doesn't touch the dot at the middle there, then we're going to definitely take away marks. So those small things, don't be too excited. Remain calm, draw and collect all the marks. And the marks are always telling you, reminding you of the number of forces that we're expecting you to draw. Because it's 4 marks, definitely in your head, you are able to see that we're expecting to have at least four marks. Now, calculate the magnitude of the tension in the string. Calculate the magnitude of the tension in the string. That is for 4 marks. So at least this one is for the tension on the string, and then the free body diagram that you have drawn, it had on the 4 kg, it had the tension. So you are able to see that, okay, the forces that we're having our tensional force going up the incline. We're having our frictional force that is opposing motion in the opposite direction. But now, what is important now is that we have our weight that is at an angle because we're going up the incline. So definitely now you must be able to resolve our weight into the horizontal and vertical component. So you must be able to have your perpendicular component like that, which is your Fg parallel or W perpendicular, and then you have your weight, which is parallel. So you are able to see that your weight or your Fg will have Fg perpendicular and Fg parallel. And we are saying this Fg perpendicular or weight perpendicular weight, we are saying is equals to the normal force. So they cancel one another. So our focus in terms of the forces are the forces that are acting where the object is moving. The object is moving along that direction up the incline. So our focus will be in those forces, and then it's up to you to choose the positive direction. Where tensional force is going can be positive, or where the other 2 forces are going can be positive. And without wasting time, you are able now to do your calculations. To say you have chosen that up the incline is positive, then definitely T will be positive. But if you have chosen that up the incline is negative, definitely your T will be negative. So always choose the positive direction because we are dealing with vectors. And then the other forces acting, a kinetic friction, it will be negative. Your Fg parallel or your parallel component of weight will be negative as well. And that is F net equals to ma. We always apply Newton's second law in this case. And then you are able to do the substitution. You were given the kinetic friction on A, which was 5,88. You were given our mass, which was 4. And then you were given as well, G is 9,8. And then don't forget the Fg parallel or the parallel component of weight is mg sine theta. Please don't forget that. Your m for mass, your g for gravitational acceleration, sine, our angle that we're given, it was 35. You are able to substitute it there. And with that done, you are able to calculate the tension. You just simply make the tension subject of the formula. Everything goes transpose that side, and then you are able to collect all your marks. I hope it helps you. Whether you have chosen up the incline is positive or negative, the two are shown. The next question was on the force. Calculate the force F, and then you have seen that force F was acting on the 9 kg block, which in that case there was a tension as well that was pulling the 4 kg block. So now, meaning that now you must be able to have a free body diagram or a force diagram that will show you all the forces acting on the 9 kg block. I just want to emphasize here that don't make a mistake of using the system approach, because we're going to penalize you. So you apply Newton's second law to the 9 kg block alone. If you get the answer, it's fine. If you don't get the answer, you will go and apply the Newton's second law on the 4 kg block and then simultaneously be able to solve until you get the answer. In this case, we applied F net equals to MA on the 9 kg block, and then we said the forces now that are acting on the 9 kg block is the applied force, which we had positive in this direction. We have tension that is opposing the motion going backward. We have kinetic friction. We have the parallel component of weight. So you are able to see all those forces that you have identified, and then that is equals to MA. Immediately when you do that, you rest it, you substitute, and after your substitution, you are able, don't forget the mass is no longer 4 kg, we're talking about the 9 kg, and then just use the calculator, you get your correct answer. So I'm hoping you will practice as many of those questions as you remind yourself. This you have done in grade 11, you have revised in term 2, it was part of your junior exam. Even now, as you prepare for your prelim, you are still doing this, and definitely you must be able to collect these marks. Now, without any wasting of time, we will move to vertical projectile motion. You know your exam guideline, which you said that's your Bible. You have it close to you. You have it with you all the time. You keep it close to yourself, because as you are revising, you are having the exam guideline. You are able to tick what you already know. Now, the exam guidelines say you can explain what is meant by a projectile. Remember, we're just saying a projectile is an object upon which the only force acting is the force of gravity. Remember, we are saying that our projectile has been given an initial velocity. It has been given an initial velocity for it to be a projectile. We said it has been given initial velocity, and the only force acting upon it is the force of gravity. And then when you differentiate from free fall, we're saying projectile is an object which has been given initial velocity, and the only force acting upon it is the gravitational force. And then when it comes to a free fall, we're saying this one now, we are referring now to an object. We are referring to motion. So projectile is an object that has been given initial velocity, and the only force that is acting upon it is the force of gravity. And then we are referring to free fall as a motion, of which the only force acting upon it is the force of gravity. And we are saying be able to remind how to sketch those graphs, be able to, for all the scenarios, be able to draw the graphs, be able as well, when the graph are given, to determine the velocity, to determine the position, the displacement, and position. And then we are saying bouncing ball, the bouncing ball as well, you must be able to know how to do the calculations. And then the object that is thrown upwards, and the vertically upwards, and the object that is thrown vertically downwards. You'll see we're going to do the questions now, and then you must be able to remind yourself about that. I've emphasized what a projectile is to say this one is an object. And then when it comes to free fall, we said this one is motion. What is an object? What is a projectile? We said it's an object which has been given an initial velocity. Write it in full, and then it moves under the influence of gravitational force only. But when it comes to free fall, We are saying this one is motion, during which the only force acting on the object is the gravitational force. So we are saying at least these two definitions for this question on vertical projectile motion is a song. You must be singing them by now. But our data sheet, very much important. Our equations of motion, that you know them. The graphs, I've emphasized that you must be able to draw the graphs. And then, as always, problem solving strategy in terms of this particular question. We are saying put critical points in your trajectory. Always start by drawing the trajectory, followed by the projectile. So draw it. You know, they say seeing is believing. So when you see something, at least you know what is happening because you have seen it. You have seen it. When you have seen something, when you draw something, you start to see it. And when you see it, you'll be able to answer questions based on it. And we are saying as you draw your trajectory, be able to put critical points, the point of launch, the maximum height, point of launch as being A there, the maximum height, you know at the maximum height we are saying velocity there is 0. And then point symmetrical to the point of launch, C there. The symmetry. Remember we talk about the time symmetry and the velocity symmetry. To say from A to B, the time is the same as time from B to C. So we talk about time symmetry. So if I know time from A to B, definitely I know time from B to C. And then we talk about the velocity symmetry as well. To say if I know the velocity at A, it means I know the velocity at C. The difference there, it is the sign. It is the sign. If upward is positive, it means time at A will be positive, but time at C will be negative. So those small things, they are important. And to say as we pass C, we are expecting that the velocity is increasing. So definitely those are things that you will always take into consideration. And we are saying choose sign convention. Always tell us which one is positive. Choose the positive direction and do your data collection. You have 5 variables under equations of motion. Is your initial velocity, final velocity, acceleration, change in y, and change in time. Definitely the rest that table, collect the data before you answer the questions. And then we are still emphasizing here the constant magnitude and direction of G, to say G is always 9.8 meters per second squared downwards. Please don't forget that. Always remember that. And we are still emphasizing the formula, substitution, answer with correct SI unit and direction, but direction is only for vectors. So without any wasting of time, let's go to questions. As I indicated, we want to focus mostly on dealing with questions. Let's look at this one. A person dives from a high platform into a pool at which one of the position A, B, C, D will the magnitude of his momentum be a maximum. So you can see that this question, it is integrating the topics, because as we were doing vertical projectile motion, we had an understanding. We talked that when we start at D, definitely this is our projectile. It has been given initial velocity. Now you can see our object here is a person. He's diving. So here is diving. From there with initial velocity, goes up, reaches maximum height, then it starts to fall there, going down. Now you can see that if I draw a point here, maybe let me call it D1, so that you are able to see. We talk about velocity symmetry, to say the velocity at D and the velocity at that point of launch, that is the same point of launch. When the object reaches there, the velocity is the same. So you are saying if I left here with 10, it will decrease to 0, but it will become minus 10 here, which is equal in magnitude, but in different direction. Definitely, as I pass point D, definitely the velocity is starting to increase. It's always more than 10. It increases until A. Just before the diver reaches the pool, definitely will have maximum velocity. So at which point, the question was, at which will the magnitude of his momentum be maximum? At which point? So you're able to see that at A here will have maximum momentum, because momentum is equal to mv. So when v increases and we have maximum v at A, definitely the momentum will be maximum. So that is your integration as well of topics. And then let's take now a previous question paper as well and deal with it in order for us now to revise our vertical projectile motion. Now a ball is dropped. So already you can see a ball is dropped. from rest, from the top of the building, 15.2 meters high, after a ball has fallen 3.2 meters, a second ball, so it's not only one ball, the first one was dropped, initial velocity 0. So you know here that it was dropped. Dropped means initial velocity is 0 meters per second. And then the second ball, which is B now, is projected. Initial velocity cannot be 0 here because now it's projected upwards. So it has initial velocity. And then after a while, the two balls strike the ground at the same time. So what is important is that these balls, they are going to strike the ground at the same time. Ignore the effects of air friction. You know the importance. I think when you see that statement, you are the happiest, because that statement is saying the only force that is acting upon these objects A and B is the gravitational force. So that statement is there to qualify, to say we only have one force acting on A and on B, which means these two objects are undergoing free fall. They are undergoing free fall. Remember, free fall, we said, is a motion. It's a motion of which the only force acting is the gravitational force. So they are saying define free fall. You're saying, oh, free fall, yeah, these two objects, they are all under free fall because the only force acting upon them, is the gravitational force. And you can see B, you see that it's a projectile. It has been given an initial velocity, because we're saying a projectile is an object that has been given initial velocity, and the only force acting upon it is the force of gravity. So I think you are seeing the whole topic here. And then the first question was, calculate the time taken, 3.2. Calculate the time taken for the ball to strike the ground, ball A. So important to know which ball you are responding about. Don't confuse all of them. And then immediately, when you talk about A, you are able to say, okay, what do I know about A? What do I know about A? I know that initially it was dropped. A was dropped. That is the first thing that you know. You know that change in Y is 15.2. You know that gravitational acceleration is always 9.8 meters per second squared downwards. You don't forget that magnitude and direction of gravitational acceleration. So you can see in your data collection, a lot of information. And the question is saying, no, all we need is time. We want to know the time that it took for ball A to reach the ground. So armed with this data collection, you are having your delta Y, you are having your initial velocity, you are having your gravitational acceleration, then you are able to go to the data sheet. Remember, you must be able to choose the positive direction. Now, without wasting time, definitely you go to the data with your to the formula data sheet. You are able to choose change in Y equals to VI delta T plus half AT squared. Definitely, when you choose upward as positive, the object was going down. Definitely, your change in Y is minus 15.2 is downwards. Your G is negative 9.8. So it's very much important to see that, when I say upward is positive, G is always going down. Definitely G must be negative. Then you are able to do that. And then you are able to trace your formula. Remember, we said initial velocity was 0. Then you are able to say 0 times delta T is 0. You have half minus 9.8 times delta T. So you solve for delta T, which in this case is 1.76 seconds. Then your routine questions, 3-mark question, formula, substitution, final answer, and then you are able to get your final answer. I don't want to waste time. We must be able to move